Okay, good morning, fourth graders. We are going to review estimating sums and differences of decimals, this time using front-end estimation. So let's do a little bit of a review of what we did with whole numbers. So first of all, this is going to be lesson 13.7, part 2, and it's called Estimating Decimals. And in particular, yesterday we talked about rounding, and today we're going to use front-end estimation. Now, let's review what we did with whole numbers. So let's say you were asked to add 32 plus 17, and you wanted an estimate. You didn't need to know an exact answer. You were buying fabric and you wanted to make sure you had enough to make something. And you needed 32 yards and you needed 17 yards. Okay? So what you would do is you would take the front digits, you would add them together, and then you would make everything that came after that a 0 and put about in the answer. Okay? If you needed to, that was to estimate the sum. So the sum of 32 plus 17 is about 40. And then the actual answer would have been 32 plus 17, which would have been 9. It would have been 49, and that's reasonable based on our estimate. Okay? That's sums. Well, what if you were asked to do a difference? What's the difference between 79 and 15? Well, with whole numbers, you would, again, using front end, you'd take the front end digits and subtract them. 7 minus 1 is 6, and make everything 0. Put the word about in your answer. So 79 minus 15 is about 60. And you can see that this is a good estimate because if you did the actual subtraction, your answer would be 64. And that is reasonable based on your estimate of about 60. Well, nothing changes. The rules are exactly the same for estimating sums and differences of decimals using front-end estimation. So let's say that you were given the decimals. Let's see, what does your book give you? 83 and 41 100ths, 83 and 41 100ths, plus 71 and 3/10. And you have to estimate it. So I always tell you that when you're going to do an estimation, you should first put the word about in your answer, or you could abbreviate it ABT, so that the person knows you don't really think that this is the exact answer. This is an estimate or an about answer, an approximation. Well, you do the exact same thing. You're going to add or subtract the first or front non-zero digits. So in this case, it's 8 plus 7. 8 plus 7 is 15. Everything else becomes zeros. So in the ones column, you've got a 0. Then you've got your decimal points in alignment. Your tenths column gets a 0, and your hundredths column gets a 0. So no matter, I'm going to make them in different colors so you can see them better. All you did was, in this case, add the front digits. Okay, another example that your book gives you, let's try a subtraction problem this time. What if you were given 9 and 3/10, 9 and 3/10 minus 4 and 76 100ths. 4 and 76 100ths. Notice how I've lined up all my digits based on the decimal place. You do the exact same thing. Now, just because this has 3 digits and this only has 2 doesn't mean that this bottom number is bigger. Okay? If you were going to compare 9 to 4, you would know 9 is bigger. So 9, you exact same thing. Subtract the first or the front digits. 9 minus 4 is 5. Put your decimal point in, Everything else becomes zeros. Put about in your answer. If you can remember to put the about in your answer at the end, you can wait to the end. It's probably a good idea in the beginning to put the about in the answer first. So 9 3/10 minus 4 76/100 is about 5. Okay? What if you were given something like this? Because remember, it's the front non-zero digit. So what if you were given 60, let's write it in orange, 65/100 plus 5/10. And you had to do an estimate, okay? I'm going to put my about in my answer so that I don't forget. Now I'm going to look at the front or the first non-zero digits. So we're not going to do this because those are zeros. We actually have to go to the next one, 6 and 5. So I'm going to put my 0 and my decimal point in. You know what? I'm actually not going to do that now. I'm going to, let's rewrite this problem so we can see it better. 65/100 plus 5/10. There we go. Now we can see it. I'm going to put my about in my answer so I don't forget. Okay, about. Now, like I started to say before, you're going to your first non-zero digit places and you're going to add or subtract them. Well, these are zeros, so I can't do there. So I'm going to go to my tenths place because that's where both of them have a non-zero digit. Okay, so I have 6 plus 5. Before I was going to subtract it by mistake. It was written in orange and I was having some trouble seeing it. So now that I wrote it in green, I can see that this is a plus sign, not a minus sign. So 6 plus 5 equals 11. So I put my 1, but I can't put 11 in the tenths column. So I have to carry 6, just like I would in the whole number addition. 6 plus 5 equals 11. I put down my 1 and I have to regroup 10 of my tenths into one whole. Don't forget to put your decimal point because now I've got 1 plus 0, which is 1. And then everything else becomes a 0. So when you have 65/100 plus 5/10, it equals about 1 1/10 or 1 10/100. You don't have to put that 0 there. You can, but you don't have to. Let me see. What if we had another one? What if we had a subtraction one that was like this? 67/100 minus 4/10. Okay, the rules stay the same. You're going to add or subtract the first or front digits that are not zeros. So these are zeros, so that's not what I'm going to subtract in this case. I'm going to put my about in my answer. I am going to put my decimal point in my answer because those are two important things that I do not want to forget. Now I'm going to do 6 minus 4, and that's 2. And then everything else becomes a 0, and then we always put our 0 for whole numbers in there. So this is about 20/100. Okay? Alrighty, that's it.